In this lesson, we are going to learn how to draw patterns with shaders. All right, now that we know how to use shaders, we know about vertex shader, we know about fragment shader, we need to practice, and we are going to draw using shaders. You will see what I mean by that. Yeah, first, it's because we often need to draw shapes. Like, I don't know, maybe you want to draw stars, which is something we will do a little later. Maybe you want to draw circles. Maybe you want to do like a light lens in a Michael Bay's movie style. Maybe you want to draw waves or stuff like that. It can be to see those patterns. Maybe you want to see, I don't know, light. It's for the inside of a particle, something like that. And the light can, I don't know, rotate, stuff like that, and combine different colors, which can look great. All right. But it can also be to move the vertices. Like if you want, I don't know, let's say a sea, a water with waves doing stuff like that, you kind of need to draw the waves, but with black and white, and use this value in order then to move the vertices. We are going to do that also later. Anyway, we need to learn how to draw things. We could use textures, that's true, but the problem of the textures, first you have to load the texture. So it can be like a really huge and long texture to load. Then you have to provide it to the GPU. It will kind of overload the GPU if you put too much texture, so it's not that good for performances. And also you don't have control over it. The textures cannot be animated. If you want to tweak the values of the frequency of the waves, or maybe the star, the rotation of the star pattern, stuff like that, you won't be able to do it unless you go to, I don't know, GIMP, Photoshop, and you change the pattern on that. So you will get more control, and you will be also able to animate those. Just like we animated the flags, so it was kind of a wave pattern, and we animated this wave pattern. You cannot animate the same way by using textures. The problem is that to draw, all we have are coordinates. I will show you that, but maybe you can guess what coordinates, and our mathematical skills. Well, what mathematical skills, you might ask? You're probably as bad as me in math. Do not worry, it's going to be about practicing, just trying to find the right value. You will see in the next part that I'm not that good. I just need to tweak the value until I get something right. So if you are good at math, great, you're going to be you're going to go fast. If not, do not worry, it's just about tweaking and testing value unless you get the result you want. We are going to draw many patterns from very simple gradients. All right, we are going to start very simple to very complex, like Perlin composition combining with sinusoid stuff and very complex things. But we will start simple and then do complex things. It's the perfect opportunity to practice and to learn how to use the function I talked about in the previous lesson. There was some kind of a clamp, mix, step, cos, sin, we know those. We are going to learn those. It's a good way to practice. So the setup, as you can see, all we have in the setup is a plane looking like purple. All right, great. We have a shader material already set. So this is the one we are going to practice creating the shaders again in the next lessons, but this one is already set up. So this is a shader material, not a raw shader material, meaning that we already have some uniforms, precision, stuff like that, prepending also attributes prepended to the code. We are going to have a look to the code next. The shaders are located in the shaders folder than the test folder, because there is only one test material. So it's this one. This is your JavaScript here. So it's script.js. Then the shaders folder, then the test folder. Here is your vertex. Here is your fragment. We are going to spend most of the time in the fragment, but still we are going to do some modification in the vertex. Anyway, you can open those, open the vertex, open the fragment, and we can go forward like that. All right, cool. First, because we are going to draw, by the way, we're going to draw on that plane, meaning that I will ask you to draw a gradient, then some squares, then a star, then some Perlin shape stuff, sinusoid complex thing inside that on that plane. So it's going to be in the fragment part, all right? It's going to be over there. Currently, all we have is this. If I change the value, I don't know, I put 1, 0, we get something like pink. All right, so we have control over it. It's functioning. But to draw on that plane, we are going to use coordinates. And maybe you guessed it, we are going to use the UV coordinate. And it's usually like that we do draw shapes on a plane. So, the UV are attributes. Maybe you remember, don't do it, but I can just show you, look at my screen. So we close this. Geometry, attributes. I'm going to show you the geometry attributes. We have the normal, the position, and the UV. All right, this is the UV coordinates. There is not much to say about this one. Anyway, we can access the attributes here. So let me guess. Yeah. By doing, you know that, we have to do attribute. It's a vec2, so I'm inside the vertex shader, and UV. This is the way of fetching, retrieving the UV attribute of each vertex. I save, I get an error. What did I do wrong? Well, it's because I'm trying to get the UV, but I already got it because it's a shader material. Don't forget that. So if you look at the code right here, maybe I can just increase the console. The error is UV redefinition. Yes, it seems like when we added this, we had an error. And if you look closely, you will see that in the prependy code, so this is not my code, as you can see, it doesn't look the same. We have a position normal after, we have something about tangent, before, and something like tangent after, but still it's exactly what we wrote here. And it's because we're using shader material, and shader material prepend all this code. And then we added this one. This is our attribute vec2 UV. So we don't need to do that. What we need to do is send it to the fragment. And to send data from the vertex to the fragment, we use varying, like that, singular. It's going to be a vec2, so we keep the same dimension. I'm going to say that. VUV. I always prepend by V, I think it's better. And then what you can do is VUV equal UV, so you just update this varying. You save, you get a warning telling you that you created a varying, but you are not using it in the fragment. So the next part is in the fragment. We're going to fetch the varying. Do you remember how we do that? We just write varying vec2 VUV, exactly the same definition here, varying vec2 VUV. You can see that it's exactly the same between vertex and fragment. And then we can use it. So I just save. All right. I'm not using it right away. I'm going to lower this. We don't need, so we still have an error because we are getting the UV, but we are not using it. So it's the WebGL and Three.js is pretty smart here because he knows that we are not using it, so we better just get rid of it. We are going to use it, obviously. So the UV. Maybe you remember about the UV, so it's about 2D coordinates, and it's used to place textures or stuff like that on the geometries. Here we are not going to use the UV just to place a texture, just like we did with the flag, you know, with we put a flag textures on a plane. This is the common use of UV, but right now what we are going to do is use those coordinates just to be able to draw. Those coordinates, by default for a plane, it can be different if you create your own geometry, I don't know, with C4D, with Blender, 3ds Max, stuff like that. You can do whatever you want with the UV. But the default UV of 3ds plane is going to be on the, so it's X and Y. So X is horizontal, Y is vertical. And we are going to have 0.0. On the right, it's going to be 1.0. And at the middle, the X is going to be 0.5. All right, that's all. There's no surprise. Maybe you already understood that. And for the Y, it's exactly the same. We got 0.0, and here we get 1.0. And when we are at the top right corner of the plane, it's going to be well 1.0 and 1.0. Right? I'm not going to write this one, but it's works like that. Those are the default UV coordinates of a default plane where we didn't change anything. So this is the X, this is the Y. Great. And this is all we have to draw things on this plane. We're going to use those coordinates to create shapes. We are going to draw circles. We are going to draw gradients, like grids, like random values, something that look really like natural. You will see how. And we will go step by step. I'm bad at this. You will see that maybe the first one I'm going to be okay, but you will see at a point I will struggle. And you will probably struggle, maybe not. I hope not, but it's perfectly normal. And you will see the process of just trying to understand and to find the right value. The idea is that I provide you a pattern. So this is the first pattern. And then what you have to do is get this result here. Maybe you can just follow me, just watch the video and do on the same time. But my recommendation now is to try on your own to get this pattern, to get this result. I want this on this. You can do it. It's better for practicing. So just pause the video when you see the pattern, try 1 minute or two, and then maybe you got it. Congratulations, maybe not, and we do it together. It's all about practicing. It's not a test. So yeah, I showed you the answer. Anyway, to get this result, we already did it. Maybe you remember from the previous lesson. What we are going to do is inside the glFrag color, put the two first value with the VUV. So it's going to be VUV-X and VUV-Y. And 1 here. So we are not going to play with the alpha. It's not that important. We could, but it's not that important. But we are going to play with the RGB, or you can say X, Y, Z. To get this result, we put the last one, so the B at 1, and then we use the VUV-X and the VUV-Y at the X and the Y. We save, and we get this result. So it's exactly the same. This is the exercise you're going to do. By the way, there is a more simpler way of writing this. Instead of providing each value, you can do just VUV, like that. Because it's a vector 2, the first two values of the vec4 is going to be X and Y of the VUV. And we get the same result. All right, this was the first pattern. If you didn't got this one, it's okay. Maybe you forgot how we did it in the previous lesson. No worry. The pattern number 2 looks like this. How can we get that? You pause. I'm not going to do a pause like that when I'm talking, so you have to pause quickly. The idea is that I'm going to change the blue part to 0, and we get something like this. All right? And this is kind of a famous pattern too. When people are testing the UVs, they get this kind of color. So maybe you saw it in, I don't know, video games, tests, engine, 3D engine, stuff like that. Game engine, sorry, I meant. And what I like a lot is by putting 0.5 here. I don't know why I really like this color. It's a mix between the two previous. So it was 1 before, then it was 0. I put 0.5. I really like this color. Anyway. So this was the second pattern. We have a lot to see. And it can go pretty fast. At least the first one, it will go pretty fast. The next pattern is going to be that. And we are going to do some changes right after this pattern. So how do we get this one? Pause the video, try, and then follow me on that. It looks like it's only black and white. To get black and white, we need the same value. I don't know, let's put 0.5, 0.5, 0.5. It's kind of a grayscale. All right, this is the way of getting a grayscale value. We have to use the same value on each of the RGB, not the alpha. If I put 0.2, it will look darker. If I put 0.8, it will look brighter. But right now we have some kind of gradient. And as you can see, it's a gradient that starts at 0 and then it's going to increase from the left to the right. And we already have a coordinate that increases from the left to the right. It's the VUV-X. It starts at 0 and on the right it's 1. So you're going to use not just a value you put here, you're going to use the VUV-X. We use that VUV-X on R, G, and B of the color, and we get that. All right, I think you're starting to see how we are going to draw with that. This is the base. We have coordinates, and by using mathematics, by using the right value at the right moment, we get what we need. Next one. Oh yeah, no, by the way, little changes we're going to do here, little change we're going to do here. Right now we are going to draw only a black and white pattern so that we can just focus on the shape, not combining R, G, and B. It's just easier to focus on the shape. Later we're going to play with the color, stuff like that. We're going to mix those shapes with color, you will see. But because we are going to use grayscale black and white result, we are going to instead of writing the result here every time, what we are going to do is create a variable. So it's going to be a float, and we are going to call it just strength. And the goal of the next pattern are going to set the strength, because we are simply going to use that strength on R, G, and B of the frag color. All right, I just moved that. We are doing exactly the same thing. It's just that now we are going to focus on the strength here. So what I also recommend is to start saving those. I'm going to use a pattern. It was number 3, something like that. Yeah, was it? Yeah, it was the number 3. And keep this because it might get useful later. It will get useful later. So save those. And this way, if you want to get back to a pattern you did, you can, because you will just have to uncomment it. All right, and then we send the result to it. So it's exactly the same thing. It's just that now we are using a variable. Do that. Pattern number 4. Can you do that? No surprise here. What you need to do, so duplicate it. I might forget to duplicate. Comment the previous one and call this one 4. All right. And how do we get a gradient that starts like that and then that goes up? We replace X by Y. Like this, and we get this gradient. Or it's just the gradient, but on the Y like that, because it's going like up. The value starts at 0 and then goes up. That's all. No surprise. I don't know if we are going to use the drawings a lot. Maybe when we are going to start like sinusoid, rotation, stuff like that. Anyway. Yeah, that's the result. Pattern number 5. Well, that was quick. Let's hope this one is easy too. All right, how do we get this? Go ahead, pause the video, try. Now I'll show you the result. We want to start at 1 and then go down. Well, it's the VUV. So it's 1 minus VUV. So we do 1 minus VUV. And I did a mistake here. I forgot 1.0. So it starts at 1, and then because VUV Y is going to increase, well, this value is going to decrease. We save, and we get the opposite. So it's a gradient starting from the top. It's 1 minus the VUV. Next one, pattern 6. Oops. Number 6. How do we get this one? It looks like it jumps much faster to the value. All right. Actually, it starts black at the bottom. So maybe it's not 1 minus something. It's more like the previous one we had here, because yeah, it's black at the bottom. But as you can see, in just few pixels, it's already 1, and then it stays white. Actually, maybe it's more than white here, like more than 1 here. Maybe it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 maybe. I don't know. Well, what you can do is simply multiply the VUV by, I don't know, maybe 10. Let me see. Yeah, it looks like it. Maybe it was 6, maybe it was 15, I don't know. To me, I think it was 10. We are going to check that. But anyway, the value starts at 0, but goes up faster because we multiplied it. Let me check. Yes, it was 10. All right. And now we are talking. Pattern number 7. I hope it's this one. Yeah. Look at this one. Things are getting harder. As you can see, it starts the same way. So it goes from 0 to 1, just like we had 0 to 1 here. So I think we have the right base. So this might be the start of the pattern number 7. But then it restarts at 0, and then goes up again, and then it restarts at 0 and then goes up again. And we already saw that. When you want a value to goes up and once it reaches a limit, it starts again, and it starts again, and it starts again. It's like having like a value that goes, well, I'm going to draw like to the right, but it's not exact. So it goes up, 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 and once it reaches 1, it restarts, and you do like that, and you do like that, and you do like that. And the great thing would be to be able to control how far it can go. And maybe it's 1.5, and whoop, it restarted, up, it restarted, and it restarted. And we can start to draw those kind of patterns. It's a modulo. We need to use modulo, just like I told you about the modulo. I don't know which lesson it was, but we go to a value and then restart at 0 and go to the value. To use the modulo, you cannot use this percentage. You have to use a function. So it's the mod function. We do mod. We provide the value that is going to increment, and then the limit. All right, this is the way I see modulo. If you look at the definition of modulo, it's going to be different, but this is the way I always use modulo. It's kind of reaching a limit and going back to 0 once this limit is reached. I save, and here you go. I know we have a huge aliasing, but it's not the problem here. We are not going to fix the aliasing. If you are using a display with a higher pixel ratio, you probably don't have aliasing. All right. So this was a new one, but now you know about modulo, and we are probably going to use it a lot. Oh, that's the next step. Here, maybe you can see that it's kind of the same repetition, like, 1, 2, 3, 4, 5, 6, there is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we are probably going to use the same one. So I duplicate this, I call it 8. And the idea here is it's like we have a limit. Like if the values is below 0, we stay at 0, else we want 1. Can we do if in GLSL? I don't know. Let's try. If, so duplicate the pattern, is the 8th. If strength inferior to 0.5, I don't know, let's try just like in JavaScript, maybe, equal 0.0. Else, strength equal 1. Maybe, finger crossed, it did work. Great. So we can use if. Don't use if. I know it's tempting, but conditions are bad for performances. Conditions like that are bad for performances. If you don't have a choice, do it. If you have a choice, avoid doing it. And we are going to do another solution. It's just better for performances. Try to avoid doing if, else, stuff like that. But let's talk about it again. Can you remove those curly brackets? Yes. So if you want to use them, you can. Can you do like a ternary condition? I don't know. If ternaire. We say that in French. If ternaire. So it looks like this. So it's like asking a question. If the answer is yes, I want this value. If the answer is no, I want this value. Can we do that in GLSL? Yes, we can. Great. This is cool. We can do that. But still, this is like a if you can avoid doing a if. And we are going to avoid it by doing strength equal, and we are going to use a step function. All right. And the step function, it's like when it reaches a limit, it will be 1. And before that, it will be 0. So it's kind of the same thing. So you provide first a limit. So my limit is 0.5, and then a value. So it's my strength. If the value is below 0.5, step is going to provide me 0. If the value is above this limit, it will, the step will provide 1. So it's kind of the same result, but we are not using a if. We save, and we get the same result. And the funny thing is that we can play with this one. It's about controlling the pattern. So if you want to do a if, maybe when you begin, when you're a beginner, do if, it's okay. But if you want to optimize things, you better use those kind of function, better for performances. Pattern, next pattern, it's going to be the 9th, pattern number 9, and it's this one. And the great thing with doing patterns in GLSL in the fragment is that we can just control things. Like if I put 6, you will see that, right, the black part is bigger. If I put 3, it's mostly the white part. So here I think it's something like 8 maybe. Yeah, it's look like it. So we just change the step limit. So if it's below 0.8, if strength is below 0.8, it's going to be 0. If strength is above 0.8, it's going to be 1, which is why we get this result. All right, next one. So it's going pretty fast. We're going to spend more time on the next one. Unfortunately, you will see. Number 10, we have this. I think you can guess what we are going to do. So I just duplicated the 9. It's not on the Y, it's on the X. All right, that's all. We are using the X value to control the pattern. Great. Next one. So it's going to be the 11. I always duplicate, but sometimes we are going to cut and start in a new pattern technique. So this one is 11. And we get this. Can you guess? It's a combination between the previous one and the new one. So let's go try to do it. The problem is that you're starting to have a lot of code here. And this is where there are many ways of doing it. I will do it, it's a mix between my way and the way I want to show you how to do things. And yeah, it's going to look like that. The idea is that we are going to combine them. So what I will do is that I will take the mod and put it inside the step here. So I take this value and put it inside the strength, and I just use it like that. It's exactly what we did, but in one line of code. This way I will be able to combine them more easily. What I want to do then is to combine with the one doing horizontal lines. I will simply add to this strength the same formula, but using the y-axis, like that. This, and as you can see, oh, never mind, we have to add it. I say add, but I wrote equal. So we start with this one. It's exactly the same as before, but written in one line. So it's a step, and inside the value here, it's my modulo. As you can see, it's this modulo. And then I add, so I can do plus equal, the same formula, but with on the y-axis. And we get this result. So we can start to commenting. And maybe you can do like a plasma shield that the player cannot go through or something like that. And later you will see that you will be able to animate it, make the thing do a strange like deformation. Well, that's for later. Anyway, next pattern. Let's see what we got here. And this is where you start just to try things. We get this. How can we get this? I can give you a hint. You just have to change one thing, one character. It's going to be this one. Instead of adding the vertical to the horizontal, or maybe it's the opposite anyway, we are going to multiply them. Multiply, and as you can see, we get this. So I show you the previous one, where the line cross, we multiply, we can only see them where the line cross because we are multiplying them. Next one. 13. Yeah, it's over there. Maybe it's from the same base. Yeah, it looks like this. All right, it's kind of the same thing, but it looks like it's larger. Here is the perfect moment to show you that I will just test values. I don't know which one is doing what. I think it's this one, yeah. I think I have to play with maybe this value. All right, I think it's the step. Maybe, maybe not. Let's try. I'm going to put 0.2. Yeah, that was the right value, but I used the wrong that was the right position, but I used the wrong value. I think it's more like 0.4. Yep. So I just changed the step of the first one. Maybe I can show you what it was. It was this one. All right. So the first one, I just changed the step. This was the previous result on the X. And I said, no, now it's going to be like that. So it's bigger. And then I multiply with the previous one, which is the same, like that. Okay, cool. Let's duplicate it. And now it's going to be kind of a mess. You will see why. It's the number 14 and it's that. All right. What can we do here to get this result? It looks like it's a mix between this and the same thing on the other axis. How can we get this result? Well, this is the moment where you better use new variables. And we are going to draw the bar on an X. So the bar, let's say the X bars and then the Y bars and then combine the result. All right. This is the general strength. It's like we did a draw bars. So maybe we can call this one, instead of strength, we are going to call it bar X. All right. Because we are drawing bars on the X and then we are going to focus on drawing the bars on the Y. And finally, we are going to merge them. So rename the strength bar X. What you can do just to make sure that everything is working still, you can do like strength equal bar X, like that. It's a new one, so I have to do float strength because strength didn't exist before. So, all right, we get the same result. It's just that the drawing the X bar, we put it inside a bar X, maybe bars X. Anyway, I think I put bar singular. And then we are putting it there. Then you can duplicate this part and focus on drawing the bar on the Y. All right, we don't care anymore about this one. We'll get back to this little guy later. For now, we can even comment it and rename this one bar Y and show it by changing the strength. Look at this, we get the same result. Now, what we need is to draw the bar more vertically. All right, we want to draw the vertical bar and then we will combine them with the horizontal bars. What we can do here is 4 and 8. Maybe, I don't know. Yeah, it did work. All right. I just focus on drawing vertical bars and I just inverted this one and this one. And we get this. We have the bar X. We have the bar Y. Should we add them? Multiply them? I don't know. I'm going to try to add them. So it's bar X plus bar Y. So the strength is a combination of them. And yeah, it's working. Great. It's kind of long. Actually, there are better ways of drawing those patterns. I know, but I want to capitalize on what we did before and improve to show you that usually a complex pattern, it's just a combination of small steps that give you the final pattern. And yeah, you can draw this in very different ways. And you can try, by the way. So let's continue. Maybe it's kind of the same pattern. Yeah, it's this one. Instead of drawing those kind of arrows or corners, something like that, we are going to draw like plus, big plus signs. What can we do here? Well, I'll let you try to guess this one. I think it's just about offsetting the values. I'm not sure about this one. Like really, trust me on that. I'm not sure about how to get this one. So I'm going to try. I'm going to focus on the Y. I want my Y, so the bar Y, so the vertical bars, to move a little on the left. What can I do here? Maybe I have to move this one, minus 0.2 maybe. Yeah, something happened. Maybe it's plus 0.2. Oh yeah, it's it. All right, that was lucky. I really didn't know what to change exactly, but the VUVX, I just offsetted this result by using 0.2. All right, I'm not even sure this is the right way of doing it, but still it seems to be working. So yeah, why not? It seems to be working, so let's use this one. And can I do it on the X too? So for the X, I think it's going to be on this one, because we did it for the bar Y, so the vertical bars, I change on the modulo using the X coordinate. And for the bar X, so the horizontal bars, I think I have to change it on the Y. Let's test. Yeah, it did work. Okay, that was really lucky. It was kind of random, but still it did work. I'm not sure it's 0.2. Let me check if we zoom on it. No, it looks like it's perfect. I would have thought maybe 0.25. Let me check with 0.25. No, this one is wrong. Still kind of nice. 0.2. Yeah, because the thickness is 0.4. All right, that's why. And I won't lie to you, this is the way I do it. I'm bad at math. I just try stuff until I'm happy with the result. And at the end, it always makes sense. Like oh yeah, it's 0.2 because I have to offset this one because I'm taking care of the vertical one or the horizontal one. And it's 0.2 because it's half of 0.4, and 0.4 was the thickness of the bar, and it kind of makes sense. This part probably went too far for you. Anyway, it's just about practicing. If you tried, this is already great. Next one is the 16. All right, we can forget about this one. It got really complex. I insist on the fact that there are more simpler way of writing this. So let's comment this one and create a new one. And it's kind of a gradient. It looks like the first gradient we had. So let's do the first gradient. It was strength equal VUVX. All right. And we had something like that. So yeah, that's not very far from this one. So pause the video, as always, try to do it. Maybe what I have to do is kind of offsetting it. I can try plus 0.5. No, it's the opposite. Now it got even brighter. Maybe it's minus 0.5. Oh yeah, so we have a part here that is working. So we have a values that goes from, maybe I can show it to you. We had a value that goes from 0 to 1. So it went 0 to 1 like that. It was 0 to 1. What we did here is minus 0.5. So it goes from minus 0.5 to 0.5 like that. So at the middle, it's 0. What we can do here is use an absolute value. This way it will do from 0 to 0.5. This one won't change, but this one will go from 0 to 0.52. Because this one was minus 0.5, we use absolute values. We tell we want only absolute values. If something is negative, you will get a positive value. So it will go positive there and positive there. All right, cool. Let's try this one. I'm not sure about it, but I think that's the solution. We use the abs function. It's not math abs, it's just abs. We save. Let's see the result. Oh yeah, that's it. We offsetted the value. And then we say we want only positive value because on the left it was getting negative, and we said no, we want positive value. All right, cool. I forgot to write pattern 16. So pattern 16. The next one, I think it's close to this one, so I'm going to keep it. So it's 17. And it looks like this. Oh, how can we get this? Well, you can guess that it's going to start with this one, all right? And you can see that there is this pattern, this vertical pattern, but also the horizontal pattern like this. And in fact, maybe you would have focused on this part here, like it's brighter at the diagonal, something like that. No, in fact, it's just a combination of the vertical of this and the horizontal of this. And to do that, what you can do is maybe multiply them. I don't know. I'm going to do multiply by y. What do we get? No, that's not it. Maybe we should add them. There is some idea, but still it's not that. Divide? No. Minus? No, still not. In fact, this shape you can see, it's the minimum value between the horizontal one and the vertical one. Look at this. You probably could not have guessed it, but still, if you did, great job. But you have this, you have this, and this pattern is the combination of the minimum value. All right, it's the minimum value between the two patterns you just saw, and we can use minimum. I'm going to cut this one. I do min, and then I provide two values. So it's going to be the x and the y. This is the base shape. Then we use the y I have to change this one to Y, and it's the minimum value, and we get this. All right. I know you probably could not have guessed this one, which is why we are learning it right now. All right, the next one is the 18. This one you can guess, I think. I'm not sure of it, but I think it's what I have in mind. This is the maximum value. All right, it's a combination of the previous gradient and the same on the vertical axis, maybe horizontal, vertical anyway, but this time it's going to be a max. And yeah, it looks like that. All right, yet again, if you didn't know about this, you probably could not have guessed. Anyway, this is why we are practicing. So let's comment this one and let's go to the 19. Yeah, it's going fast. Great. Pattern 19. Oh, that looks completely different. Maybe we should get rid of this one. No, because there is kind of something here. As you can see, it's like a square. It's funny because it's like a corridor, and we can see like a ghost at the end. Anyway, but we can use this pattern to get this pattern, and we already know what to use to get that. So just pause the video and try to find something from the previous part that can be helpful to achieve this result. And to achieve this result, we are going to use a step. Because the value is going from 0 to, I don't know, maybe 0.5. It doesn't look white, so it's probably 0.5. So we're going to use a step, and the limit is going to be something like 0.2, 0.3. So put all of this inside the step. So I cut it, I put a step. First, I think it's the limit. Yeah, you have to provide the limit, not the value. So let's try 0.2, and then what we calculated in the pattern 18. And yeah, we get this. Is it 0.2? Let me check. Yes, it's 0.2. All right, it's exactly the same. Good. So we can like draw frames. We can draw a square, but in fact it's more interesting to talk about the white part. We can draw the frame, and it can be the frame of anything you want. Pattern 20. All right, what's that? So it's funny because there is a much more simpler way of doing it, but still we are going to do it by using what we have here. So I'm going to duplicate here because it looked like it's starting with what we have here, and it's a smaller one. How can we get this? Well, it's a combination of two opposite squares. I insist on the fact that there is better ways of doing it. So maybe you did it in one line of code, a much simpler one, but we are going to capitalize on what we have before. And what I'm going to do is create another square that is the opposite of that. Look at this. I'm going to comment the first one. So this one, this is the square. You can see it here. Sorry, it's the previous one. What I'm going to do is do the opposite. I do 1.0 minus the step, because the step return something. It's 0 or 1. If you do 1 minus the step, it's going to be the opposite. So it's going to be 1 or 0. So if I save, you can see that I get the opposite. I know there is better ways of drawing a square, but anyway, you can get a square by doing that. And here we're going to change its size. We're going to change it slightly. We can do it like maybe bigger. Is it bigger or smaller? I don't know. We will see. So as you can see, I have this square. It's slightly bigger, and I have the opposite, which is slightly smaller. And as you can see, look at this edge here. I'm going to switch between them. Look, it's right here. There is a part in our squares where we can combine them. We are going to multiply those two values. All right. What you can do is do, I don't know, maybe square 1, then square 2, and the strength is going to be the first one multiplied by the second one, like this. And we get it. All right, we multiplied those. I can show you again. This is the first one. All right, this is the second one. All right, and we have like a union between them, an intersection between them that should be the final pattern. So to get this, we have to multiply them. I think I did slightly different from the lesson here, so be careful with that. Not sure. Anyway, it's getting harder. I know that. The next one is this one. All right. Every time it gets really hard, we go to another exercise. So great. It's going well. The next one is going to be the pattern 21. Pattern 21. We get this. So it looks like the first, how do we say, the first gradient we had. So let's get back the first gradient. So it was float strength equal VUV dot X, like that. But now it looks like a low quality gradient because we have some kinds of steps. How can we get that? It's not that easy. To get that, we need kind of rounding to maybe there is something like 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there is 10 of them. It's like rounding to the first decimal. It's kind of that. To get this result, we can use round, but round will simply round the value. So we provide a value and we give you 1 or 2, and as you can see, it's not working because if the value were before 0.5, we got 0, and if it's above 0.5, we got 1. What we need to do here to get more precision is that we are going to multiply it by 10. So now it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It just goes too fast. What you can do now, you cannot see it, but trust me, there is a part here. It's 0. Maybe I can just add some. Look, I will do plus 0.1. No, maybe more, 0.5. Yeah, you can see that there is a slight part here. What we can do here is divide it by 10. And we get this. Oh wait, there is a slight problem. Let me check why. Why do we get this? Oh yeah, it's because it's not round. My bad, it was floor. Floor will round to the bottom values. Like if it's 0.8, it's going to be 0. If it's 0.9, it's going to be 0. And if it's 1, it's going to be 1. And if it's 1.2, it's going to be 1. All right, this one was a little harder. We crank the value up so that it goes from 0 to 10. Then we applied a floor, which is a round to the bottom value. And then we divide it again by 10. So we get again a value from 0 to 1. Okay, great. The next one, it's going to look like that. It's kind of the same thing, but combined with the y, so a y gradient. So we are going to start from the 21, and we are going to combine it. And can you guess if it's like mean, max, plus? Well, actually, I think it's just strength multiplied by the 1 on the y. Not sure of that. Yeah, it is. Great. So it was a 22, looking great. We can continue. 23, let me check what it is. Oh yeah. I don't know what you're seeing in the video with the compression, but right now it's just like the old TV, you know, the very old cathodic TV where we could see like a just like in horror movies. How can we get this result? Actually, there is a problem here. What we need here is kind of a math random. We don't have math random in GLSL. Yeah, that's a problem. So there is no native random value. So this one is, we are not going to use the previous pattern. So you can put anything here. So UVX, and we are going to change that anyway. So yeah, there is no native random function in GLSL. Random doesn't exist in GLSL. Actually, random is not, never existed even with using a CPU JavaScript. It's kind of a pseudo random, but still it looks random. But right now we need some random thing inside the GLSL. And there is just a function. This is the function. There is multiple function, but this one is probably the most used one, where you provide a vector to, and it will give you back a value from 0 to 1 that will look random. It's not, but the value is so unpredictable that it will look random. All right. The funny thing is that you will always get the same value. If you provide, I don't know, 0.5, 0.5, we'll always get the same value. But anyway, let's use this one. So it's a perfect opportunity because we can just add a new function to our code. So take the function, I put inside the link, you have the links, but also inside the lesson. You can just write it again. And if you want to learn more, well, you have the book of Shader. We talk about the book of Shader, and we will have like an explanation on how it's working and how to use it. And the function is over here. All right, it's this one. If you want to go to the website and take the function, it's this one. I just changed the line breaks and stuff like that. So yeah, take this function, put it before your main function, save just to make sure that there is no error. So no error right now. And we can use this function. And to use this function, we're going, instead of using that, we're going to do random. It's a function, so you add the parentheses and you provide VUV because you need to provide coordinate, 2D coordinate. So it's a vector to this random and we get something like that. All right, looking great. If you move the camera, you will see that it's a mess, but anyway, we get the result we wanted. So yeah, this is what we did. Next one, it's kind of the same thing, but with big stuff like that. All right, we get like big random values. The values won't change if I move the camera in this. The black one will stay black, the gray one will stay gray, and the white one will stay white. But still, it's kind of random. You can guess that it's combination of the one we just did here and the previous one. I can show you the previous one. It was this one. All right. The idea is that instead of providing the VUV, we are going to provide this coordinate. This way we get the same value here. For every pixel here, we are going to have the same coordinate because you can see that it's the same color. The gray is the same here, than here, than here, than here. So we need those as the coordinates that we send to the random function. So let's go. I'm going to call it, let me see. I want to do a close to the lesson. Yeah, it's going to be like that. We are going to create a new UV. We are going to call it vector, and it's going to be grid UV. And it's going to be a vector, like that. And for the X, we are going to use the X we had at the beginning where we had, strips, vertical strips, like that. We can put under it. And for the Y, it's going to be the same thing we did with the Y. All right, this is what we did before. This is the pattern we did before, but instead of multiplying it, I use the horizontal stripes as the Y of the grid UV and the vertical stripes as the X of the grid UV. And then we provide this vector to grid UV to strength the random method. And we get an error. What did I do wrong? Or you can guess it. I forgot a semicolon right here. And we get that. And funny thing is that we get exactly the same pattern. And if you can refresh, you will always get the same pattern because it's pseudo-random. This is not true random. If you refresh, because we provide the same coordinates, we get a random value, but always the same random value. All right, great. Let's continue. And it will look like this. All right, this one is the same, but it's kind of being offsetted. The idea is that we are going to offset the grid UV and we're going to offset on the Y depending on the X, or is it the opposite? On the X depending on the Y. I think you can do both. No, I don't think you can do both. Anyway, let's just try. So it's going to be the 25th, sorry. So yeah, we can get this one. Oh yeah, okay, that's it. We are going to offset the VUV-Y depending on the VUV-X, all right? The VUV-Y, as you can see, it looks like it goes down or maybe up anyway. The VUV-Y changes depending on the VUV-X. So we have to change maybe this one, and I will do, I don't know, I will just try. You know what? I will just try. VUV-X. So I add the X to the Y of the grid UV, and I get not the right value. All right. So maybe it's like that. Oh yeah, that's it. And can I do it like that? Yeah, that's it. There are many ways of doing this, so it's really up to you where you want to put it. I think I did it differently in the text version, but yeah, that's kind of my limit. I just try until it looks good or not. It's way too strong, so maybe we can just use 0.5. And yeah, this one is looking exactly the same. Yeah, that's it. It was 0.5. All right, that's a way of doing it. Great. And you could have do it differently. I think in the lesson I put it like maybe over there. And it was maybe 0. Multiplied by 5. Let me test. Yeah, okay, that's the same result. It's the same, actually, mathematically speaking, it's the same thing. Okay, which one is the next? Okay, as you can see, yet again, it got really hard. That was my personal limit. Let's try a new kind of pattern. And it's going to be this. How can we get that? So let me just get something on the screen. I'm going to use vuv.x. All right, we get this. So as you can see, it's kind of a dark spot at the bottom left, and then it goes to the white, and over there it's fully white, and it continues like that. To get that, it's actually more simple than what you can think. It's the length of the vector. It's the length of VUV, because VUV is 0, 0 here. The further you go away, the higher it is, but it's in every direction. So it's from 0 to 1, it's from 0 to 1, it's from 0 to 1 that way. All right, this is just what's happening here. Let's clean a little. Yeah, you know what? Let's clean everything. Maybe we need it later, especially with angles and stuff like that. So it's just the length of the VUV, because it's starting from the bottom left corner, and then it increases with the distance. How can we get the length of the VUV? Well, what you can do is simply length VUV, and that's all. And it's working. Great. You can get the length of a vector 2, of a vector 3, of a vector 4. It just provides you the length of the VUV. So here it's, white, because it's 0, 1. Here it's white, 0, 1. And because it's the length of a vector, it goes in every direction in a way. So we get 1 here. We get some kind of circle. And we are going to draw circles. All right, it's the exact same pattern, but starting from the center. There are many ways of doing that, and I think I went for, this one. It's going to be, actually I will show you the two main ways of doing it. What you can do is offset the VUV by doing minus 0.5, or is it plus? No, it was minus. This is one way. By doing minus 0.5, it's like it's starting from the center. So 0, the VUV 0 is going to be at the center here, where I have my cursor. So the 0 is going to be there, not there as it was before, because we did minus 0.5. So this is one way of doing. Another way of doing it is by using the distance. We are going to use the distance between the VUV. So this is the VUV, and we're going to ask the distance from, I don't know, a point anywhere we want. So the point can be here, the point can be here. It will provide us the distance between those VUV and the point. So we are going to use distance. We provide the VUV at first, and the second parameter is going to be vec2, and the center, it's going to be 0.5, all right? I don't have to do 0.5, 0.5, I can just do 0.5, and the value will be used for the x and the y. And the funny thing is that we can change the position of it. I can put 0.2. 0.2 is supposed to be over here, so it's working. I can put different value, like 0.8 on the y, and it's here. Maybe I want it on the bottom right. I can do 0.8 and 0.2, I think. It's on the bottom right. I can play with that. So it's the distance of the UV coordinate and the point I chose, and I chose to put it there. So it's the coordinate over there. For us, it's 0.5 because it's starting at the center, but you can do whatever you want. So, okay, it's right here. Great. Next one. 28. We did more than the half. Oh, sorry. So this one was, oh, wait. Did I do a mistake? 27. Oh, I did change the previous one. Yeah, okay. Let me get it back. My bad on that. So this one was the length. This one is the 27, like this, and it was this. And now it's the next part, it's the 28th. All right, that's the one. And we get 28th. My bad on that. You probably didn't do it wrong. So how do we get this? Well, it's kind of the opposite. So you know how to do the opposite, just like we did at the beginning. There are multiple ways of doing it. The term opposite can mean a lot. But what we can do is 1 minus the distance. So it starts at 1, and then we subtract the distance. So it starts with a bright value, and the further we go, the lower the value. Then this one. So it looks like it's the same but smaller. Maybe we can just multiply it, like I don't know. That's not the same. That's a good idea to just multiply it to reduce it, because it goes faster, because we're doing 1 minus this value, where it goes faster. But if you want this, it's a very specific formula. You have to start from a very, very small value. I don't know the exact value, but I will start with 0.01 and divide it by the distance. And we get something like that. Yeah, it's too small, but maybe I can change 0.2. Yeah, this one looks more like it. Let me check what is the exact value so you get exactly the same thing. It's 0.015, like that. All right. I won't be able to explain you this one. It's if you do a graph, it's kind of the value starting at extreme values and dropping really fast, and then getting close to 0 and staying close to 0. And it's just really useful if you want to create like a point light effect, like it's a star or something like that, and you can control it with this one, this little guy here. You can just change the value and you get very different results. All right, and it looks like this. Very useful if you want to create stars and stuff like that. Be careful, our plane is that big and we are just using a small value, and the other problem is that here it's not 0. Remember the point? Maybe I can just slightly increase the value. No, I won't be able to do it. I can try. Let me test. Plus 0. Yeah, you can see that. So I just crank the value up everywhere by adding 0.25 so that you can see the limit of the plane. But the problem is here, the value were not 0. All right, when you use this formula to get this light point effect, you never reaches 0. All right, so if I remove this plus 0.25, here it's not 0. And it can be a problem, like in some situation, you might see the edges of your plane or stuff like that. Anyway, that was a new thing. 13, it's kind of the same one, but stretch. And this is one of the parts where I don't know what I'm doing. I think we have to play with the VUV. Maybe we have to multiply it by a smaller value. Let me test. Oh, everything is gone. So maybe we have, oh, it's just on the X. So we have to be careful with that one. By the way, it was 30, like that. I don't know. I really don't know. I think we have to create a new UV. I'm going to do vec2 light UV. I'm not sure where I'm going. I'm going to do vec2 here. Don't forget the semicolon. And I'm going to start with the same one. So it's X and Y. So this is the exact same thing. As you can see, I create a new one based on the previous one. So it's the X and the Y, and I didn't change anything. And then I'm using it. We get the same result. But right now, I have more control over the X and the Y. I don't know which one is the right one, but still we can try. I'm going to do multiply by 2 maybe. All right, it got squeezed. So if I do multiply by 0.2, it got stretched probably on the right, 0.5. Yeah, see, we have something here. Maybe we have to offset it and then do minus 0.5, like that. Maybe plus 0.5. All right, it was plus 0.25. All right, we can stretch it, so it's half of it. So maybe if I do 0.2, it got stretched a little more. And then because it's 0.2, this one is half of this one. No, it was not this one, so maybe it's 4, 5. Yeah, this one is better. All right, like this. As you can see, I'm just testing, and I'm quite sure I did a very different formula inside the lesson. But here, this is the way I do when I cannot really figure out how to change it. There is some meaning in that, because this one is 0.2, and we start at 0.5 and do minus the half of this one. All right, so if I do 0.1, this one is to be 45, because it's 0.5 minus half of this one. So there is kind of logic here. I can understand the logic, but I don't know why exactly it's doing that way. And on the y, maybe it's different. So it was bigger, so maybe I have to do 0. Is it supposed to be bigger? So it's 1.5. It will change its position. Oh no, actually you have to stretch it also. So we can do 0.5. Yeah. Plus 0.25. I think this one was right. Yeah. And now we have the same result. I just tested value until I got this one. Good mathematicians probably just cried seeing what I did here. But it's my way of doing it when I don't know. And see, I got it. So it's at the end, it's what's important. All right, cool. Let's continue. The next one is going to be strength. Sorry. So this was the result. And as you can see, it's not the same. Yeah, I did think quite differently here. Yeah, anyway, let's continue. Oh, this value was not the same. Yeah, I also changed the strength for a bigger one. Anyway, it's just one way of doing things. So what's that? How can we get that? Maybe you can guess that, in fact, it's a combination of the two previous one. All right. So let's try to get this one. So I have the light UV. It's going to be a mess. So I'm going to duplicate it. I'm going away from the lesson right now. Anyway, let's try to improvise. We have this one. I will put it in one line just to get everything in one line like this. So it's the light UV. I'm going to call it X because it's like this beam. X. All right, we get the same result. And then we need a 1 going up like that. So I'm going to duplicate it. I'm going to call this one like a float light X equal and use this value like that in order just to separate the X and the Y and put this one here. All right, we get exactly the same thing. Why I did that? Well, it's just like we did before. So in order to do the same on another axis. And I'm going to use VUVX, so this one is going to be Y, so I change it here and here. We don't care about this one anymore. Then the light X, it's not going to be light X, it's going to be light Y, and we get on the Y, so we have to change the X, it's going to be Y here, and X here. I know I'm going fast, but it's because I don't even know where I'm going. Anyway, it seems to be working. Great. And then we can combine them. I don't know by using what. I think we need to multiply them. So it's going to be the X multiplied by the Y. Finger crossed. Yeah, we did it. It's not exactly the same because in the previous pattern, I kind of messed and I went far from the initial path. But still, we get the same pattern. Not the exact same shape, but the same pattern. I know it was fast. And the next one, it's the same, but being rotated. Oh no, what can we do to get this one? So let's duplicate everything. Obviously, you can refactor once you're done with it. You can just combine them and put it in one line and maybe mutualize some operations. So this one is the 32. And what we need to do now is to rotate this shape. We are not going to do it mathematically on what's existing here. What we are going to do is rotate the UV coordinate. You see that UV coordinate we are using for the light UVX, light UVY, stuff like that. Instead of using the VUV, we are going to use a rotated UV. And to do rotation, we could spend like a half an hour explaining how to do a rotation on a point. So you have a point and you rotate coordinates on that point. I'm not good at it. I'm not an expert at all, and it will take half an hour. So instead, we are going to use a function. All right. So is it the 32? Yeah, it is. So you duplicated the previous. We get the same result. What we are going to do is take this rotation, you can take it from the lesson, just scroll a little on the page and take it, or you can just write it again. And we're going to put it, so pause the video, get the rotation function, it's on the lesson page, put it there, just like we put the random value. And to do a rotation, it's a mix of cos, sin, and offset at the right moment, at the right place, with which point is the center, so the pivot point. It's all about that. And right here, what we want to do is create a rotated value. We can use it, just use it in order to see that it's working. So we are going to create a, I think it's rotated UV. So we create a new rotation. And we are going to do, let me check. The name is rotate. So it's the new function. Its name is rotate. And to do the rotation, well, you provide the UV coordinate as the first parameter. And then you need to provide an angle. And for the angle, I don't know what I'm doing for now. I will just put, I don't know, 1 watt. Well, maybe you can guess. And at the end, you have to provide the pivot point, and we want to rotate on the center. All right. If we have a point here, we want it, no, let's say like right here. If we have this point here, we want it to rotate on the center right here. So we want it to do something like that. All right. If we have a point here, we want it there, because we want our shape that looks something like that to look something like, it's hard to draw, like that in a way. So we have to rotate just slightly like this. I don't know about the rotation exactly, but I know where is the pivot point. It's 0.5 and 0.5. So let's go. I can provide as the third argument vec2 0.5. All right, it didn't work. Yes, because I rotated the UV, but I'm not using this rotated UV. So you have to replace every occurrence of VUV by rotated UV. And it seems to be working, but I provide 1 as the angle. What if I provide, I don't know, 0.5? What do we get? All right, looking better. Maybe I can just try to guess it, 0.8. Okay, I like this one. Yes, we just eyeball it and say, all right, that's cool. Instead, you can guess that we are using, we need pi, because it's radians. We need to use pi. Can we access to pi? I don't know, let's just do pi maybe like that. No, it's not working. Maybe pi like that. No, maybe it's a function. No, you don't have access to pi like that. You're going you have to provide it. So you can do it. We can do float pi equal, and see it's 3.1415, something like that. It's actually true. And we can then use it there. Yes. Well, you can take the code I provide you in the lesson. So maybe we can put something like that. It's more precise, and use it inside the angle here and find the right value using pi. Yes, we can do that. It will work. But because pi is a value that will never change, it's a perfect opportunity to show you the define. When you have a value that will not change and you would just want it to be available, you can create a define. So let's go. Usually we put the define at the very beginning of the code, and we say hash define. You can call it pi. I like to just call it pi. Some people will do mpi. You can put pi in lowercase, but anyway, we usually use uppercase for constant, for defines, so that we can see them more clearly when you're using them in the code, and we are not tempted to change it. And to provide the value, well, you just write it. No equal or stuff like that. You just provide the value. Yet again, just scroll on the code, on the lesson, to get the exact value. So we save. And now, how much of a rotation we want to do? Remember that this is the rotation we want to do. It's this part here. So we start from this, and we want it to go there. All right. It's that angle here. Pi is doing that. All right. It's half of a circle. Sorry. Up, 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 up. Like this. This is pi. So how much of pi do we need here? So this is over there, over there, over there. Yeah, it's 1/4 of pi. We want to rotate 1/4 of pi. I know angles are not easy for everyone. They are not easy for me. Anyway, it's 1/4. So we can do, instead of trying to eyeball the value here, we can do pi multiplied by 0.25 or divided by 4. It's up to you. And we get the exact angle. I know it's the same result because we were probably pretty close. Math, pi multiplied by 0.25. Yeah, it's 0.78. We did 0.8. I know that's close, but now it's perfect. It's the right angle. So yeah, that was a big one, probably very far from the lesson. Anyway, next one, it's going to be the 33, so it's pattern 33, like that. And it's circles now, and we actually can draw it quite easily. We are going to use, I think, it's the one we had before. So strength, it was the distance between the VUV and the point, which is VEC2. So it's the center, this one. So we start from this one, I think. So as you can see, we did that one before. Remember, it was over there. We get the distance of the VUV coordinate from the center, and the center is 0, 5, 0, 5, because it starts at 0, 0 and at 1, 1. So the center is 0, 5, 0, 5. We did this one. But how can we get this pattern? You know that. Remember when we draw our first square, we have to use a step. So step, then the limit, I don't know, maybe 0.2. I'm not sure of it. Let's see. And then we provide the same value here. All right, that's it. It's not 0.2, it's 0.25 maybe, so that it's bigger. All right, we did draw a circle, kind of like we did draw a square. The 44 is going to be this one. How can we get this one? Well, I think the start is kind of the same. Maybe it's the distance. Can I start with the distance? Yeah. And remember the gradients, like we had a gradient that goes from 0.5, 0, 0.5. Well, it's kind of the same thing here. Maybe I can do like minus 0.25. Let's see. Yeah, it's going far pretty quick. Maybe it's 25. Yeah. And because this part here is getting really like below 0, what we can use is apps like that. Yeah, looking great. I think it's this one. This one looks a little brighter. Let me check if it's the right. Oh, sorry, it's 34. No, that's the right value. It's just the compression of the image, maybe. Next one, we're going to draw this circle. So we have almost everything here. It's a combination of the two things we did. We just need to combine it with a step. So step, you provide a limit, maybe 0.1, and then the value, and we get something like that. And it looks much smaller, so maybe like that. All right, it's 0.01. This is a way of drawing a circle. Who knew that drawing a circle could be that hard? Indeed. And I think the next part is going to be the opposite, exactly. So sorry, it's 35. This one is going to be the 36. And to do the opposite, well, because the step returns a value which can be 0 or 1, we do 1.0 minus that to get the opposite. So instead of having 0, we have 1, and instead of having 1, we get 0. 37, all right, it's like it's starting to look strange. So this one is kind of the same pattern, but with variation like that. And you know a pattern that do that, it's a sinus. So we're going to apply sinus, and it looks like the sinus changes with the x. All right, so we're going to apply a sinus on this one. We are changing the UV coordinates, so we are going to create a new one. Let's see the name of it. It's going to be waved UV. All right, that's such a great name. So we are going to change the UV. So we are going to create a new UV. So it's VEC2 waved UV equal VEC2. And we are going just to take the UV here. So it's going to be VUVX, VUVY. Right now I'm doing the exact same. I'm just kind of duplicating the VUV and using that wave UV here. So we get the same thing, but now we can modify this wave UV. By the way, you cannot modify a varying All right, you cannot just modify varying, you have to create something new using the same properties. So because it's on the X, yeah, it's on the X, but it's moving on the Y. See, it's moving on the Y depending on the X. So I think we have to change it over there, and we have to do the VUVX and add some sinus to it. It's probably going to be way too strong, and the sinus will vary depending on the VUVX. Okay, maybe it was it. Maybe not, I don't know. Let's try to have fun with it. I'm going to multiply it. I think that's it, yeah. And the amplitude of sin, remember, it's from -1 to +1. It's way too much because my UV is going from 0 to 1 and 0 to 1. And we had a huge amount that can go from -1 to +1. So it's too much. Just multiply it by, I don't know, 0.1. Okay, that's pretty good. It's doing the thing, but maybe the strength, I think it's enough. But the problem is the frequency. The frequency here is much bigger. Let's try 30. Oh, okay, that was 30. Perfect. And you get this result, and you can have fun if you want, maybe 100. And you get this kind of spooky. But anyway, let's keep the 30 like that. Okay, that's cool. The next one is, what did I do here? Yeah, let me check the values. Yeah, 30, 0, 1. Use that wave UV. Yeah, that's all. We are close to the end. Hang on, guys and girls. We are almost at the end. So, 38. Hang on. It's this kind of the same deformation, but also on the X. Well, because we have it here, let's just take this formula, the sin, and put it there. And instead of making it change on the X, we're going to making it change depending on the Y. And yeah, that's the exact pattern. The next one, 39. I know it's a long thing. Take a nap, do some pause. Go at your own pace. It's important. Don't force yourself to learning things. You need to rest. Oh yeah, I really like this one. How do we get this one? So is it the 40? No, not yet. It's the 39. I think it's just a matter of like cranking this value up. Let me test. Yeah, that's it. So it's not 300. Okay, I think it's 100. And yeah, it's looking great. Did you imagine you could draw something like that by using shaders and sending a program to the GPU that would change a plane on a library that can do much more? I mean, it's completely crazy. Anyway, looking great. Yeah, if only we could animate this. Just saying. 40. Yeah, it's the 10 last. We are almost there. I think it's going to be funnier. Oh no, it's about angles. It's not that funny, for me at least, because I'm bad at mathematics and I hate angles. So how do we get this? Well, this is actually just an angle. So I kind of spoiled you on this one. If I get, let's just get something on the screen. VUVX, we get this. All right. To get this, it's kind of an angle. It's an angle of a vector 2. All right. So we have the vector that is doing, let me just clear this. Like that. We have our X doing like that. We have 1 doing like that. What you can see here, it's just that angle like that. All right. It goes from zeros and then plus something, plus something, plus something. And I don't know, maybe it's 1 over there. Yeah, I think it's over there exactly. So this one is going to be 1. So it's just an angle. We need this angle. It's the angle of the VUV, and to get the angle of how do you say, of a vector, you can use a tan. All right. So float angle equal a tan. As always, there is documentation, stuff like that. So just check the links. I provide you some documentation before, some links to glossary, stuff like that. Just check them. And we're going to use the VUV. Yeah, the A10, I think you have to provide 2 values. It's not a vector 2, which is kind of strange. There is probably a reason for that, but anyway. So we provide 2 values, the VUVX and VUVY, and you will see that we will simply get the angle. And instead of showing the VUVX, we provide this angle. We just want to see this angle. And yeah, that's it. That's the angle. it's kind of strange that we get 1 here. So no, it starts at the top. Actually, I'm totally wrong on what I was showing you here. So the orange one is wrong. In fact, we get here is this angle, right? The angle starting from the top and then falling on the side. Sorry for the previous drawing. Anyway, we got this. As you can see, I'm really bad at angles, but still we got this one. And then we can kind of get the same, but starting from the center. And I think what you have to do here is just offset those. Am I right with that? I'm not sure. Yeah, that's it. Instead of getting the angle starting from the center, so this was 0, 0, so I'm going to use red. So this was 0, 0. We just do minus 0.5, so now it's the angle starting from here, and we get this angle here. And it goes from 0 to 1 quite quick, it seems, because yeah, we get 0 and 1 really fast. But now we want to have 0 here and 1 when we do a full circle. And this is the part where I just try value until I get the wrong one, the right one. Oh, sorry. So this one, I did it again. I forgot to duplicate. My bad. So this is the one we did here, like that. Let me check. It's not too bad if you don't saved it. So yeah, it was, no, the 40 was this, and the 41 was this. Okay, let me just check the 40 that I didn't broke it. Yeah, that was the 40. So this is the 42. So we start from the same value and we want something that goes from 0 to 1. All right, and right now all we have is this. So we are kind of far, but still we have an angle. I don't really know, but one thing I know is that I'm going to use pi. Remember the pi? We need this one. Maybe I will start by doing angle. You see that it's going too fast. See, it's 0, 1. Okay, it's already too fast. Maybe I can just divide it. So divide by pi. It won't be enough, but still you can see that it takes more time. But still it's going way too fast. So maybe divide by 2 times pi, like that. Don't forget 0.0. Yeah. So this is the right value. It's just that it's starting here. So maybe I can just offset it and do angle. I'm just trying, I'm not sure. Oh no, I have to add pi because I want it to start at 0. So you can see that it's probably minus pi here, 0 pi. I think that's the problem. So I will do angle plus equal pi in order just to add more. No, that wasn't the right thing to do. I know. 0.5 maybe. Yeah, you can see I just tested it because I divided by 2 times pi. It was going from minus 0.5 to positive 0.5. So I just needed to offset it a little to get from 0 to 1 on a full circle like that. It's looking great. Okay, cool. I think I did it differently in the lesson. Anyway, let's capitalize on this angle. So as you can see, it's kind of joining what I already say about values. I like values that goes from 0 to 1. It's always better to have clean values that are not impacted by the rest everywhere. So the next one is going to be this pattern, and we already did that. It was with just a gradient, but this time it's not on a gradient, it's on an angle value. And what we need to do now is do a modulo, so strength. So you have to multiply it, so multiply by 10, 10.0. So as you can see, it will go like way too fast. So it just crank up really fast. It's probably like 20, we are going to see. And then what we want is that when it reaches 1, it starts again at 0. It reaches 1, start again at 0, reaches 1, start again at 0. So to do that, you can use modulo. So angle equal modulo. Modulo, I always forget if it's which one is the first value. Let me check. Yeah, so it's the value. So it's going to be the angle. And the limit is going to be 1. All right. When it reaches 1, I want it to go back. All right, looking great. But instead of 10, maybe we can do 20. Yeah, I think it's even more. Oh no, it's I think that's it. Yeah. And if you want to have fun, well, have fun as always and send me those. And we can see some moire pattern. I don't know if you can see the moire pattern. Because we are perfectly centered, it looks really strange. Yeah, that's crazy. Sorry. Anyway, let's continue. 44, we are still capitalizing on the angle. So let's get back to the angle. So 44, like that. My angle, I can remove those multiply by 100. Oh, sorry, it was not 100. It was, which I think it was 20. All right, I fixed the 43 to get the right value. And this one is 44, and this one, so I remove this part. So I remove the multiply by something and the modulo, because I just want my angle back. All right, this is my angle back. And what I'm going to do here is get a value that goes up. It looks like it uses the angle to go up and down, up and down, up and down. You see this pattern before? It's a sinus. So let's try. Maybe I can do, this one is going to be just far-fetched, like I will just try values. So the strength is going to be a sin of the angle. I don't think it will look great. All right. And I just multiply the value by, I don't know, maybe 50. Yeah, that's it. All right. I think we are going to have a problem anyway, but let me check. Yeah, it's looking great. Let me have a look of the solution. No, that's it. There is no trap here. You can just do 100. Never mind, it was much easier than what I thought. But yeah, the value, we use the angle and apply a sin on it so that it does something like that. All right, cool. The next one, yeah, I knew it was going to be this one. The next one is a combination of what we saw. It's like a huge combination of a lot of things we saw. First, it looks like it's a circle. But the circle is being, the radius is changing depending on this value we have here. So let's get back to the circle. I don't know which one it was. Maybe it was, let me check. It's probably a step with an abs. Not this one, not this one. Let's find abs values. So this one is waving. Yeah, it looks like this one. With a step. All right, that was a 35. So this was a circle. So we get back to our circle. I don't want to write it again. So it's 45. So it was this one. Yeah, but it's the opposite. So 1 minus this. So we get this. All right, we start with the circle. And then we are going to change the radius of that circle depending on, let me show you, the previous value we calculated. All right, we're going to use this value to make the radius change. Hang on, I really don't know where I'm going here, so let's try. I think we can create like a radius variable, and the radius is being controlled over, I think it's over there. Yeah, that's the one. So this is the radius. So the radius is that. All right, I put it there. Let me check if I get the same result. I get my angle. And as you can see, if I put 15, it's going to be smaller. And if I put, I don't know, 45, it's bigger. So I can control the radius here. And what I'm going to do is use the thing we did right before in the previous pattern to control that radius. What I'm going to do is simply take this part, paste it, and instead of calling this one strength, I'm going to call it sinusoid, like that. So if I save, it didn't change anything. I just have the sinusoid value, and then I will add the sinusoid value to the radius, like that. And it's working, it's just way too strong. So I will do multiply by 0.1 maybe. And yeah, it's looking better. 0.02. Yeah, that's it. I think it's the exact same one. So this part is the same as before. It's the sinusoid thing. Instead of saving inside the strength value that I use then to show something, I just save it inside the sinusoid variable. And then I change the radius of my circle depending on the sinusoid thing. I know it was hard. And when it's too hard, we get back to different concepts. So yeah, we are close to the end. It's the 46. Let's go. And it looks like this. What is that? I don't know. Let's just put something on the screen. I will do pattern 46 and do float strength equal, I don't know, v uv.x, like that. I wrote it wrong, I think. Yes, trends. All right. What is that? It looks like clouds or maybe a water on the floor or something like that. This pattern is called Perlin noise, and maybe you've heard of Perlin noise. If not, don't worry, I'm going to explain you. Perlin noise can be used to recreate nature shapes like clouds, smoke, water, fire, terrain elevation, stuff like that. Maybe Minecraft terrain elevation is using a Perlin noise. It can also be used to animate things like the grass. You know, the grass are moving. They are not moving like that. They're moving like that with a slightly offset between those, and it looks just great. So you can use Perlin noise to mimic a nature algorithm. There are many Perlin noise algorithms, like really many different one, and it really depends on what you want to do. If you want the Perlin to tilt so that you can put the same Perlin on the side and it's seamless, if you want a very performant one, and how many dimensions you want, because you can have 2D, 3D, and even 4D Perlin noise, and probably more, but I never use more than a 2D Perlin noise. So you have to choose the right one. And there is a website, there is I think it's a GIST, GitHub GIST, yeah, that's the one, with a lot of them. Yet again, just click on the link in the links panel, and you have many Perlin noise. Maybe not all of them, I don't know, but still you have many Perlin noise in here. Be careful, some of those code won't work. There is just few mistakes at very specific position, but we're going to fix that. We're going to use the classic Perlin noise by Stefan Gustafsson. Sorry if I said it wrong. So this is the one, classic Perlin noise, classic Perlin 2D noise by Stefan Gustafsson. So you can take it. I like to keep the name of the author of this Perlin noise because it's normal, and it stopped there. So this is the code. So you can go to the website and take the classic Perlin noise by Stefan Gustafsson. And you're going to put it in your code at the beginning, like that. And this is where things like GLSLify can be really useful. Remember, at the end of the previous lesson, I talked about GLSLify, so that we don't have so many functions at the beginning of our code. It's kind of a mess, and this is a small Perlin function. All right, we're going to use bigger functions later in another lesson. So yeah, it can be useful. If you save, you get an error. But why? We just added the function. We didn't even use that function. So if I remove this, it's working. If I add this code, it's not working. Well, it's what I told you. Some of those functions just don't work. You have to provide other things. And it's because this function is using another function over there. Yeah, it's the permute function. I don't know what a permute is, but anyway, I know that it's missing. And I provided you this function. Just scroll on the code to get it. I just found it on the same GIST. There is a permute somewhere else. I don't know where, but yeah, there is one here. I don't know if it's the same dimensions, but anyway, you just provide it. Oh yeah, that's the one. You save, and now it's working. We are not using the cnoise function, so it's a noise that a function that will create our Perlin noise, but still we have access to it. And to use it, it's simple. Great. We like when it's simple. So it's the 46, yeah. And you just need to use the cnoise function. The name might differ depending on the one you took, but the one we took is cnoise, and you just provide 2D coordinates. So for us, it's going to be VUV, like that. And we get something like a big stain here. And it's just a matter of a frequency. Multiply by 10 and you will get this, and you get always the same result. And we can do so much with those Perlin noise. I've been using it everywhere. It's just great to create randomness, clouds, stuff like that, like the reflection on the water when you're under the water looking at the sand. You have some shapes doing stuff. You can do so much with Perlin noise. So yeah, let's capitalize on this one. We are going to go for the 47. It's almost the end. You did it. I don't know how many of those you did. If you did, I don't know, maybe 10 of them on your own, it's already so great. It's a great job, and maybe you're good at math and you're good at this exercise and you did all of them and you even find better solution than mine, and this is even better. Great for you. It's all about practicing. What you did here is practice, and this is the right thing to do. To get this result, maybe you can guess, we are going to use a step. The step, you have to provide first, I think it's the limit. I always got this one wrong, but I think it's the limit, and then the value. And yeah, as you can see, I said 0 because the Perlin, the one we use, goes from minus something to positive something. And actually it's not minus 1 to positive 1. It can be more, it can be less. The Perlin noise is kind of chaotic. You can have values that goes above what you expected and it can mess with your code, but anyway, it's kind of chaotic. I'm not going to explain Perlin noise, but it's great subject. I could be talking about Perlin noise and the different algorithm for hours, but let's focus on the pattern. And we did so much patterns today in this lesson that we need to go to move forward. All right, this one is looking great too. I'm not sure on how to get this one. Let me check. I think we can start from the C noise again. It looked like this, and maybe we use an apps on it. I don't know. Yes, but it's the opposite. As you can see, I have the same pattern. So when the value dropped below 0, because we use apps, now it's above 1, and we get this thing. And then we can do minus something like that, maybe. Yeah, it's looking exactly the same. I got lucky on this one. So it was 48. And then there is the 49, like that. Let me check. Oh yeah, looking great. I don't know. I think we can start from this one. And yeah, the value goes from minus something to positive something. And we are going to use this value, and I think we are going to apply a sin on it. So because the value is just like incrementing randomly, we should get something that looks like that. I don't know, maybe it's a bad idea. Let's see the result. Sinus of it. I didn't change anything. Maybe we need to crank up the frequency. Yeah, that's it. I don't know if it was 20. It looks like it. Sorry, I had the console open for a long time. Yeah, we get the same pattern, but still you can play with it and try to animate it. Please do animate this one, send new uniforms and play with it. All right, we are almost done. 50, that's it. And we get that. So it's just sharper because as you can see, we have mostly gradients here. To get a sharp thing, I think we are going to use a step, maybe 0.5. So we're going to apply a step on this one. And yeah, that's it. And we can play with the step to get a more precise thing, like 0.2. Now it was more, so 0.8, even more, 0.9 maybe. Yeah, that's it. Looking great. So now it's sharp. Sorry. See, you have a distinct between the black and white, so yeah, it's just sharp. Looking great. And you can play with everything. You can play with the frequency of the Perlin, and we get these kind of shapes. That's cool. Use the Perlin. All right, it's over for the patterns. We have few slides to do next. Remember the VUV color, the VUV gradient we had at the beginning. Let's use this VUV gradient on those patterns. So instead of black and white, I want this kind of blue purplish gradient visible. We're going to mix color. We can start with this one actually. To mix color, it's like the mix we did, you know, with the galaxy, with a color at the center, a color at the external part of the galaxy, and then we mix between the center color and the outside color. We are going to do exactly the same thing here. The idea is that we start with one color, so we can keep this strength. We are going to change what we do with this strength. So we start, I'm going to put a comment like colored version. All right. And here it's going to be the black and white version. And I'm going to comment this one and focus on this one. To do that, we first start with one color. So it's going to be a black color, but you can play with other color if you want. It's going to be a VEC3, and to create black, well, you just provide 0.0. Then we need another color. It's going to be the UV color. Remember that it was one of the first, but it was the first pattern we did. It was a VEC 3. It's the UV color. Just call it UV color equal. And we use, for the R and G, we use the V UV, and the B, we use this one. We use just one. You know what? Let's just show you again this part. So gel frag color equal, it's a VEC 4. Don't forget about this. And we use the UV color. I just want to show you the UV color again. And don't forget to provide the alpha, so the fourth value. And we get an error, my bad. VEC 4, UV color is this one. Strength, I don't know. I know we are not using it anyway. VEC, no matching overload. What did I? Oh, sorry, I wrote VEC. It's VEC 3 here. Yeah, this was the color. But I want to see my pattern instead of this huge gradient. So now the idea is that I'm going to do a mix. So it's a mix between black and UV, depending on the strength. So you do VEC 3, because we start from VEC 3 colors, mixed color equal, and we are going to use the mix function, and we are going to provide the first color. It's going to be, I don't know, black, maybe it's the opposite, or it's the one. Then the second color, and then the value that we control which one will be take. So if strength is equal to 0, we get black. If strength is equal to 1, we get the UV color. And if it's between those, well, you will get a mix between those. Let's go. And then we can use this mix color. No error, so great. And we get that. And this is looking great. See those colors? I really like those one. Anyway, we can also put the other one I like, which is with 0.5. Yeah, I really like this one too. And right now, what you can do is just test other things. Like, I don't know, maybe this one. Yeah, looking great. Maybe this one. Looking great too. And you can just test those and see the result with color. It was just to discover the mix. Anyway, we are almost done here. It's just that we have a bug. And we need to fix the strength. Look at the 11, 14, and 15. The 11 is over there. So be careful. If you uncomment one, you have to comment the previous one. So it looks like this. You can test with the 14 and the 15 too. And we get what we want, but not exactly, because look, it's just brighter between those. And this is because the value, so the strength value, so it was over there, the strength value goes above 1. And when you use in a mix, the third value is above 1, the value gets extrapolated, meaning that it will go even further than the second color. To do that, we need to clamp it, to add limits. We want to say, okay, you cannot go below 0 and you cannot go above 1, just to make sure of that. What we can do, instead of putting it here, what you can do, yeah, we are going to do differently from the lesson. We are going to put it there. You will do, I'm going to do it there. Clamp the strength. To clamp the strength, well, it's quite easy. You do strength equal, yes, GTR, let's not do mistakes. And you can do clamp. You provide the value you want to limit. So for us, it's the clamp. The bottom value is 0. We don't want it to go below 0. And the upper value, it's 1, just like that. And as you can see, the value, the strength cannot go below 1. And we don't get the value, the color being extrapolated. All right, great. You can go further. What we could have done is put those functions to draw circles, squares, stars inside functions, so that you can just take this function, use it in another code, and get the same patterns easily without having to find the part in the code. If you want to go further, well, you can keep practicing. Don't be afraid to create new shapes. It can take hours to get the right shape, but it's about learning, about practicing. And then what you can do is try to add new uniforms, because we just like put values 100, 3, 4, 5, stuff like that. But you can try to put uniforms in order to control those values, to control the patterns, and even animate those parameters, and even animate those parameters. Some of those shapes would be great if being animated. All right, take a nap first, And then let's try to animate those things and send me the result. I can't wait to see what you're going to do. See you in the next lesson.